Welcome to the DIY3DTech.com channel.
Welcome to this edition of DIY3DTech.com. In this episode, we're going to continue our Working with MakerRail series, and in this video, we're going to talk about actually V-wheels. Use some examples in a project I'm working on. This is actually going to be for a camera slide that I'm building. You might have remembered the past when I did actually be doing a complete video on this build, but I'm going to use this as an example for building the V-wheels and how this all works. And I'm going to take a little bit different tilt on this, if you will, because most of the Maker Wheel videos, there's a lot of them out there by Open Builds, Instructables, etc., etc. However, I want to talk about it maybe in a little bit different context because, again, a lot of what you see out there is them using their own plates and things like that. What I'm going to talk a little bit about is how the wheels work and then how you can use them in your own designs rather than the plates. Because you see, I've engineered my own bracket here, etc. And so we're going to talk a little bit about that too, how you can use it in your own builds. And actually buy minimal parts and make it all work in a more custom fashion, I think, if you will, than what you would get off the standard Maker site. Now, I think those things are great if you want to do something quick, if you want to do something heavy duty. However, that's not the case. I think this is a far better option. So we're going to jump in, excuse me, first looking at the wheels. As you see, I've kind of got 3 already assembled here. There's no sense repeating it all on camera or switching back and forth. So what I want to start with first is the wheel itself. This is a Durlin plastic wheel, and the idea is basically that it rides within this groove. And one of the pieces is not only can it ride in this groove, however, there's enough, and I'm not sure that this is going to get totally caught on camera, but there's enough relief here that one can put a belt through here, and this is what we'll actually do in the camera video, where the motor will track back and forth on the belt and the wheels will run over tensioning the belt. So we'll cover that a little bit more in the slider video when we do that, but I just kind of wanted to share that piece with how it sort of works. Now, what you get now, in this case, I'm using the Open Build wheels from Open Build, and you get the wheel, you get 2 bearings, 2 what they call precision shims, I'll spit that out, and a 5/16 locking nut. They don't give you a bolt, so I've provided my own number 10 bolt, about 2 inches long. That's what we'll use here, and we'll talk a little bit about that in this, why we've used the 2-inch bolt. Make some sense in a minute. So, but kind of going back to the wheel and the assembly, the first thing we do is we basically just press bearing into one side. Very easy to do, just kind of slides right in. We take one of the precision shims. Now these are, you'll get 2 in a package. Both of them are the same. Checked them with this, and actually I never thought about it. I've done a number of builds with these in the past and never thought about it, but doing this video I thought I should check, and they are both 1 millimeter, so that's all good. So that gets put in here, and that shims the 2 bearings apart. And then what we do is we take the second bearing and again insert it in here, and pretty much that's it. You have a wheel, and the bolt obviously goes through there. Now, again, the basic construct is wheel goes on, washer, if I can pick it up with no fingernails, goes on, and then nut goes on. Now the idea is this nut, again, I'm not sure if you can really see it in the video here. However, this is going to go against the top flange of the bearing, this other shim. So it's going to allow it to spin rather than pushing on the outside of the washer. So this is kind of important to understand. This is sort of not just a normal washer, if you will. It's designed for this particular size, so it makes it roll easier. So the compression is actually on the inner portion of the bearing and not the outer portion of the bearing. Because if you look, the outer portion of the bearing is actually very thin. The inner portion is actually rather wide for the race of the bearing. So this is important. This is also important when we go and start talking about the base of the build. So what you can do is, from these various companies, is you can buy your own shim. You can kind of notice that these are shimmed out from the plastic. Now these are not printed on this piece. As you can see, these are printed separate. You can get this off Thingiverse. I'll put a link on the blog where you can get this from Thingiverse. And these are very nicely designed, very thoughtfully designed. Because again, might be a little bit difficult to see, but there's actually a taper on here which matches the function of this bearing. So basically what's going to happen is if we take this apart, whoop, and I don't lose the wheel, the pressure of that, and again it's very, very small, so it's difficult to see, is going to be against the inner race of that bearing. So as you can see on these, you know, they turn rather smoothly. So and you can adjust the tension to what you want to do. I probably got this one a little bit too tight, but this one is good. So you have to adjust them a little bit. Anyways, we'll go over that in a minute. However, I want you to see how this goes. Now, the other interesting thing about this, by printing these separately and not, because you could kind of put this on here and just, you know, print it as one unit, but then you'd have to have supports and everything else, and it's just far better, I think, to print it this way. Now, one of the suggestions that came from the maker of this, or creator of this, was you print all of them together so you get the same height, because obviously this is a relatively fine tolerance in this linear track, right? So if these are different sizes, you're going to have a little bit different spacing and resistance. So it's good to print out all four of them. Now, I'd also suggest print some extra. I've done quite a few of these. I'm doing a laser build also that's using quite a few for the linear motions, and some of them broke taking them off the bed. Now, I have printed these with thick shells in ABS with 30% infill, and they work pretty darn good. So far I have had, knock on wood, no problems. So, but I have taken them off the bed because they are rather small. What I typically do is take a knife, come underneath it, separate it from the bed, and I have had them crack before where there's striations in the plastic, in this part of the plastic. So again, print some extras. I usually do about 2 extra just to have them. You can use them for spacers for other things. They're approximately 1/4 inch, depending upon the compressed first layer, but pretty close to about 1/4 inch. So again, this makes for a nice combination. The other piece is, you can kind of see if you're designing your own part, as I'm doing here, and not using one of the build plates that you can buy, is lining them up on the rail is another interesting piece, because notice that this hole is eccentric. So these two holes are eccentric, these two holes are not, so they're fixed. Now, when I did this build, I sort of borrowed some of the designs from another build, and the motor was already placed here, and I just converted it to the 28 BJY 48 motor from, I think, a NEMA 14. And so these were already here. I would prefer to have the eccentrics on the bottom and the non-eccentrics on the top where the motor is. So if you're designing it, that's the way I would suggest it. I just wanted to do this sort of quick, as in, you know, one of those quick projects to see how it works. But if I was really spending the time, that's how I would do it. Because again, when you go to do this, what you're going to do is, as we put this on here, I'll put this on here as an example, you're going to adjust this down so this is tight. And this is going to have varying degrees of tightness, and it's also going to depend upon the belt. So this is how you adjust it. Now, there's a couple different ways I would probably suggest doing this, and the final adjustment should be when you have the belt on. So I'm not going to do that here, but because I don't have the belt yet, I'm still waiting for them to come in. So once I do that, I'll actually do the camera video too. But I would suggest, you know, if you're doing it by yourself, clamping the two, and then using a socket wrench and Allen wrench to do the tightening on the bolt. And so this is tight, and this all slides very nicely. So what we're going to do is go ahead and we're going to finish out the last, let me show you how it works again. So this is the eccentric. Now, I should also mention, you can buy these in eccentric form, so you can have a straight hole here, and the bolt basically walks back and forth in it. Kind of interesting. And again, one of the things also I want to mention is, as I'm doing this, If it's a light load, this works perfectly fine. And even if for, I think, a small CNC machine with a Dremel, probably okay. If you're going to build a heavier machine, I would definitely go with the aluminum plates. This is not what I'd use for if I was using a higher horsepower, spindle or something in a CNC device. Again, this one's just going to carry a GoPro type camera back and forth across this rail. So again, not a lot of weight and not a lot of torque being placed on it. The other build I'm doing is for a laser, so it's only going to carry the laser head. So again, not a lot of weight, not a lot of force against it. So the printed plastic is fine. The tolerances are fine. However, if I was going to go with like a 1/3 horse or 1/4 horse spindle, probably would not do this design and go with the aluminum. Okay. So now that I rambled about that, let's kind of finish this out. So again, you might have to clean these out a little bit. On this build, I didn't have to. You kind of might have to thread them on a little bit because the first layer is pressed down a little bit, so it's not. But again, very nice job. So once that's threaded on, as you can see, it's now in there like that. I've pushed it all the way to the end roughly, and because it seems like that's pretty tight in that. And then what we'll do is we'll slip the wheel on, and then we'll slip the other washer on, then put the nut on. Then we'll take a ratchet with a 5/16 socket is what these are, and kind of use the belly a little bit to hold the and tighten it up. Now you're not going to want to tighten it too tight. Now this is pretty good. One of the things you're going to want to do is check to see that there's no slop, that's fully down on the wheel, but not a lot of pressure. Some of these I've tightened up a little bit too much. I'm going to have to loosen up a little bit like this one. Because you notice it's basically flush with the top of the 2-inch bolt by the time you do all this. So again, we now have our rail, and pretty much we can just slide it on there. And as you can see, here's how it works. There's a little bit of slop in it. Again, like I say, this could be adjusted a little bit more, but there's also going to be a belt, a 6mm belt this is going to ride on in this track, that these wheels are going to, maybe if I get it by the camera, that these wheels are going to press down on. So I don't want to get it fully tight now, and I can't really adjust it till then. And again, like I say, one of the things I would suggest doing, and I might do this in the camera video, because again I don't have the belt on here to fully do it, is I would take a piece of angle and put it on both sides and put a clamp, doing this by myself. This way I'll hold it tight, so you have these two is stationary, these two is eccentric. This rail will go in here, the belt would be on here, and then the clamp would pull it tight, and then you simply tighten these up, because you can see that this one's still a little bit loose, and it has come a little bit loose. Because you can also, and again, it's kind of hard diplomatically to kind of hold it like that and then tighten it, but you can get away with it. So anyways, that's how it works in linear motion. Very nice. I think it's a lot better than for a lot of these projects than the linear rod. Again, so you can slide it back and forth. You could just even build a manual camera slider like this. What we're going to do, I'll give you a little bit of a preview. We're going to put a motor in here. 28 BYJ 48. They're cheap. And then I move this over here and get this on. Is then put this gear motor there. So then what you can see is the belt will come up between these two pulleys, and sort of will come up like this around this gear, back around, and then what will happen is the gear will pull it, the motor will pull it back and forth along this. And then what we're going to do in this design is actually put stops on both sides, and when it hits one side it'll start and go back, and it'll be powered by an Arduino. And then basically what will happen is the controller board for the stepper will sit right here, and the camera will be mounted on a head right there, and it'll go back and forth. Now this is a 500 millimeter maker rail, and I'm going to probably, for the finished product, get 1,000 millimeter, about twice the length, so it can have greater distance. I'm also going to do, just to give you a little bit of future outlook, I'm going to do another one, redesign of this in the future once I build this one, where I also take and I place a stepper motor here, one of these small stepper motors this way, and put a platform on this. So as the camera moves in this direction, then it also tilts. So I can set something, say right here, and it'll maintain focus on that. So as it comes back around, it'll focus this way. So have one stepper motor moving it this way, then a stepper motor on this platform with a turntable that just tracks that position, and then match the movements of this to this one. And so anyways, you kind of get the picture. I think it'd be a neat little project and easy to do. And again, some of these I'm kind of playing around a little bit, thinking about doing up some kind of kits of these in the near future. If you're interested or see something that makes sense, or you know, let me know, and be happy to hear from you. So again, if this helped you out, we've covered how to use V-wheels, and if it did, please hit like below, subscribe. I think it's the direction to subscribe. If not, it's off to the side down corner anyways, and look forward to seeing you in the next video. Cheers.